Alright, let's continue this little discussion setup work for 5-6, and let's continue with this problem here on the right. Now with this problem on the right, let me eliminate a little bit more here, and I'm actually going to push the tempo here a little bit. So what 5-6 asks you to do is they give you a function that you see right down here in red, and they ask you, hey, what are all of the zeros, or all of the solutions? Okay, so let me get rid of all this. Okay, in fact, let me even grab something else here and even get rid of the solutions there. The question would be asking us what would be the roots. Okay, so if we learned our lesson from the first video, the first thing that you have to do when you're trying to find roots, first off, do you see why our first move is that move of using the graphing calculator? Look at that, x to the fourth minus 10x cubed plus 25x squared minus 90x plus 144. You have no factoring skills in your back pocket that I have shown you on how to factor a quartic polynomial that has 5 terms to it. All right? In fact, you can't. So the way that you would have to start this problem is you have to use the graphing calculator. So we would grab the calculator, we'd type in the function. Alright, so there you have it, x to the fourth minus 10x to the third plus 25x squared minus 90x plus 144. That's got to be the first move. Type it into the graphing calculator, hit the graph button. Okay, so when you hit the graph button, do you see now we see that graph hitting the x-axis at 2 points this time. Go to the table and confirm that those two zeros are indeed at positive 2 and positive 8. So I'm doing that right now. I've got one of them at positive 2, 2, 0. And then we'll do another one at 8. Sure enough, boom, there it is. Okay, so those are two zeros. Now, the fundamental theorem of algebra. What the fundamental theorem of algebra actually states. And now I actually will flip here. The fundamental theorem of algebra, on that note sheet that you probably have today, says that if we have a polynomial of any degree, the nth degree, there are exactly that many roots, including multiple or complex roots. In a nutshell, like I said, I'm promising you that I'm trying to be as quick to the point as I can. Pretty much here's what this is saying, ladies and gentlemen. See how this is a 4th degree polynomial? That means there are 4 answers. What I cannot promise you ever on any problem is I cannot promise you that all 4 answers are real. I cannot promise you that all 4 answers are imaginary. But what I can promise you is that those 4 answers, sometimes they might be real, some of them could be imaginary. What I can also promise you is that if they are imaginary, they have to come in pairs. The reason why they come in pairs is because of section 5-5. You can't have a plus or 1 plus 2i without 1 minus 2i, right? We talked about that in 5-5. So, our first job is to get those zeros. And so, sure enough, whoops, wrong direction. Graphing calculator, we have 2 zeros right there. We have a 2 and we have an 8. Okay? So that's what we know so far. In fact, I'm going to even write them down. Right down here in my little ledger here of my answers, my zeros. I know one of my answers, x equals 2, and I know I have another answer of x equals 8. So, to find the other ones, here's what you need to do. Once again, as quickly as I can put it, your next move is always synthetic division, and here's what synthetic division will do. Synthetic division will take the degree of this polynomial, which right now it's 4, and by dividing by each one of these polynomial factors that go with it, you can actually drop that down to a quadratic, which you can solve a quadratic with the quadratic formula. Now, notice this quick move. I'm trying to be as quick as I can, and trust me, on the next couple parts, I'm going to be even quicker and just talk about step after step after step. Now, the next step here, after you use the graphing calculator, grab the exact 0. No reversing of the numbers. No opposites here. Okay? You see it crosses at 2 and 8, you use 2 and 8. And you use 2 and 8 and do synthetic division. Okay? Let me move some of this stuff to make some room here. Okay. So, synthetic division. Grab the number that's right there, which in this case is 2. Put that 2 right there. Do you notice I did not put the opposite in there? And then we go ahead and we do the synthetic division like we're used to doing. Okay, so the 1, the negative 10, the 25, a negative 90, and a positive 144. Now because this is, by definition, is 0, guess what's very predictable? We should, if we do our synthetic division right, we should get 0 right here as a remainder. That's the definition of what a 0 is. So this should work. And if it doesn't work, if you don't get 0 right here, that means you must have made a mistake, and it's your job to go and find it and fix it. So let's hopefully this works out for us. So we bring down that, that 1, getting ahead of myself. 2 times 1 would make 2. Negative 10 plus 2 would make negative 8. And then we'd have negative 16. 25 minus 16. I think that would make 9. Isn't that right? Yeah, that would, right? And then we'd end up with an 18, which would then negative 90 plus 18 would put you at negative 70, negative 72. And then look what happens when I double negative 72. I end up with a negative 144, and hooray, hooray, we end up with a 0. Here's what you do next, okay? You take that quotient that you have right there. See that quotient? Because we just did division once, now that 4th degree polynomial now is a 3rd degree polynomial. We don't have enough tools in our tool belt to solve cubic polynomials. But this is the beauty part of the synthetic division. It's a good thing that we have a second 0 of 8. Because what we're going to do now is we're going to take that second 0 of 8 and do synthetic division again with those 4 red numbers we have right there. A 1, a negative 8, a 9, and a negative 72. If this is indeed a 0, we should get 0 here again. 1, and then 8, add those up, we get 0. We get 0, add that up, there's the 9, 8 times 9, 72, and oh, look at that, we get 0 for a remainder. Here's a question that usually pops up, Mr. Cook. Did you get 0 both times because you had to use the 2 first and the 8 second? Would we have gotten the same results if we had used the 8 first and the 2 second? That's the awesome thing about this, ladies and gentlemen, is it doesn't matter what order you do this in. This will happen every single time, okay? And it will work every single time, is that you will end up with 0, and no matter which order you choose, you will end up right here, which I will highlight in green. What you're looking at right there is a quadratic equation, right? So remember, the fundamental theorem of algebra says that whatever the degree is, that's how many solutions there are. Remember, the degree of this polynomial was 4, so I'm looking for 4 solutions. So far, the graphing calculator yielded me and gave me 2 solutions, 1, 2. That means the other 2 solutions are right here in this quadratic equation that I'm about to write, which would look something like this. X squared plus 0x plus 9. Since the other zeros are there, let's set it equal to 0 and solve this algebraically. All I'd have to do is a two-step process of subtracting 9 from both sides. And then I'd have x squared being equal to negative 9. And then I'd have to take the square root on both sides. And now I have to square root negative 9. Square rooting negative 9, doesn't that mean I have to have an imaginary answer? Square root of 9 would be 3. But the square root of negative 9, not only would it be 3i, but other answer would have to be negative 3i. Okay? So there would be all 4 of our answers right there. Okay? That is exactly what you are doing in 5-6. Let's finally look at that note sheet and show you in textbook how the textbook does exactly what I just did in the next video.